In this lecture, we will learn what a selection sort is and how to implement the selection sort algorithm in Python. The selection sort works by going through the whole collection and moving the smallest element to the beginning and then repeating. For example, say we had a collection of 5 elements in the following order. The algorithm would go through the whole collection and identify that 11 was the smallest element. So it moves 11 to the front of the collection. The order is now the following. Then the selection sort algorithm will go through the unsorted part of the collection again. It will identify this time that 12 is the smallest element after 11, so it will move 12 to index 1, the second position in the collection. Next, the algorithm will go through the unsorted part of the collection again and see that 22 is the next smallest element, so 22 will be moved to index 2, making it the third element in the collection. After going through the unsorted part of the collection again, the algorithm will find that 25 is the next smallest element and move it to index 3, the fourth position in the collection. At this point, the entire collection is in order. That is a conceptual example of how the selection sort algorithm works. The benefit of using a selection sort is that the arrangement of the elements does not affect its performance. However, the drawback to the selection sort is that it iterates through the whole unsorted part of the collection each time to find the smallest element. Now that we have an understanding of the algorithm, as well as its strengths and weaknesses, let's implement the selection sort in Python. First, we will use Python's def keyword and name our function selection sort. Our function will take in one parameter named elements, the list of items to be sorted. Inside of our function, we will create a length variable and set it equal to the length of the elements list, obtained using Python's len function. Then we will have a for loop for I in range length. Inside of this for loop will be a min index variable initialized to a value of I. One key part of the selection sort is the nested for loop technique. To pull this off, we create a second for loop, one that will be for j in range start and stop. The range will start at I plus 1. The range will stop at length. If elements at j is less than elements at min index, then we will set the min index to j. Then outside of the if statement and for loop, we will do a swap. We will start out with a temp variable set equal to elements at I. Then we will set elements at I equal to elements at min index. Finally, we will set elements at min index to temp. Note that this temp variable approach is the standard way that we swap two elements in a list and is a key part of many of the sorting algorithms we will learn about in this section. Then we will return elements. To test out our selection sort code, we will print out the result of a selection sort on a list of elements containing 2, 1, 5, and 0 in that order. When we run the code, you will notice that the elements in the list are now in the proper order. Great work. In the next lecture, we will learn about the bubble sort algorithm and how to implement it in Python.